Hello! We started our discussion on ideal auctions last time. We will give another example of an auction that is used quite a lot. In the good old days, using search engines on the internet was fairly simple. Enter a keyword and they will return relevant web pages. These days, though, the search engines found out that they could make money by selling advertising on their searches. So when you make a search, they may show ads as the first entries of a search result. One way that search engines use to select which ads to show and the order of placement for the ads on the page is through auctions that are done behind the scenes. This is called a sponsored search auction. And this used to make up more than 95% of Google's revenue. We will give a simplistic model of this auction to study. We suppose that there are K slots for sponsored links on a search results page. These are the items that are up for sale. So now we have multiple items. There are advertisers, which are players, bidding for these slots with related keywords. So they will say to the search engine, whenever this keyword shows up, we want to bid to place an ad on it. Now these slots have different values. People tend to click on the top ones more often, so the slots near the top are more valuable. The way we quantify how important a slot is using the click-through rate, or CTR. For each slot J, we let its click-through rate be alpha J, which is a number between 0 and 1. And this represents the probability that a user clicks on an ad at slot J. Typically, in a realistic situation, CTR is just under 2%. We will make two assumptions here. Assumption 1 is that alpha 1 is greater than equal to alpha 2, greater than equal to alpha 3, etc. Our second assumption is that the click-through rate is independent of the quality of the ad. This is not a reasonable assumption because the quality does affect the click-through rate. For simplicity purposes, we will ignore the quality of an ad. Now recall that we want to have an ideal auction, and this has three criteria. The first one is DSIC, or Dominant Strategy Incentive Compatible. This means that truthful bidding will give you the highest possible utility and will never lose you money. The second is welfare maximizing. This means that we are trying to maximize the total value received by all players. And the third one is efficiency in implementation. And we needed to determine two things: who wins what and who pays what. Our general approach to this problem comes in two stages. First, we assume truthful bidding, and we have to figure out how can we assign the items so that it is welfare maximizing and efficient. And this solves the problem of who wins what. Then, given the way we assign these items, how can we set prices so that it is DSIC? And this solves the problem of who pays what. Let's take a look at what this means for the sponsored search auctions. Let's start with the social welfare. We want to maximize the overall value for the players. But what is the value to a player? Well, each player I has a valuation VI, which represents how much one click on their ad is worth to them. If they are assigned a slot with click-through rate XI, then their expected value is VI times XI. So the social welfare is the sum over all players, VI times XI. For example, suppose we had 2 slots and 3 players. Suppose the click-through rates are 0.7 and 0.5, and the player valuations are 10, 9, and 2. If we assign slot 1 to player 3 and slot 2 to player 1, then the social welfare is 10 times 0.5 plus 2 times 0.7, which is 6.4. So now the question is, what is a rule that maximizes social welfare? Naturally, we would assign slot 1 to the player with the highest valuation, slot 2 to the second highest, etc. We see that this can be efficiently implemented. Sorting is not a hard problem. So this resolves number 1 above. We note that efficiency is critical. A ton of searches throughout the world happen constantly, so lots of sponsored search auctions must run at the same time, and has to be almost instantaneous. We now move on to the question of who pays what. So we want a payment rule that is DSIC, so players are incentivized to bid truthfully. Does such a rule even exist? In this case, the answer is yes, and this can be done through a more general result called Meyerson's lemma. Now, naturally, we might be tempted to generalize the second price auction. In this case, we will say that the player who wins the jth slot will pay the j plus first highest bid. We will multiply by their click-through rate alpha j, as usually, you only pay if your link is being clicked by somebody. Now we claim that this is not DSIC. Take a look at our example above and see why generalized second price auction is not DSIC. In particular, try to show that truthful bidding is not a dominant strategy. Applying the generalized second price auction for our example, we see that player 1 gets click-through rate alpha 1 and gets value v1 times alpha 1, which is 7. Their payment is then v2 times alpha 1, which is 6.3. So player 1 gets utility 0.7. But if player 1 bids 8 instead, then they have the second highest bid. So they get the click-through rate of alpha 2, and their value is v1 alpha 2, which is 5. Their payment is now v3 times alpha 2, which is 1. So their utility is now 4, which is much higher than truthful bidding. So truthful bidding here is not a dominant strategy. So, what is a payment rule that is DSIC? We will derive such a rule in the next couple of lectures.